This is Mrs. Halley, and we're looking at 8th grade lesson 4.3, finding slope from 2 points. Now, we worked on finding slope from a line and counting it, and remember that's rise over run. Today is going to be pretty similar to that. It's the same concept, but this time instead of having the graph right in front of you, you're just going to be looking at pairs of coordinates, or coordinates in the form of a graph, or of a table. So our goal is I can find the slope of a line from the table or from ordered pairs. So here's our basic formula. If you remember, whenever we counted rise over run. So we counted the number of spaces up, that went in the numerator, and then the number of spaces over went in the denominator, or sometimes it was down and over. And if you remember, I always went left to right. Now, for today, we're going to say m. Remember, slope is represented by the letter m. Why, I don't know. Is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Now, don't get messed up with this 2 and the 1. Basically, what this means is you take a y coordinate minus a y coordinate, and then you take the x coordinates that match those. And hopefully this will make sense when you look at it, because we're going to do a couple examples. So here we have an input-output table. So my input in days, output in money. So I'm going to take y sub 2 minus y sub 1. So I'm just going to take two y values. It doesn't matter which two. I picked 20 minus 15. So 20 minus 15, then I need to take my x values that match them. Remember, x on the left, y on the right. So over 2 minus 1. Now 20 minus 15 is 5, 2 minus 1 is 1, 5 over 1 simplifies to 5. So this has a slope of 5. Now I'm going to show you it doesn't matter which 2 points you chose. So here's another two, 55 and 40. And they don't have to be even consecutive. These were two that are next to each other in the table, but you can see 9 minus 6, they're not really numbers that are next to each other in real life. So 55 minus 40 is 15. 9 minus 6 is 3. 15 divided by 3 is 5. So you can see it doesn't matter which numbers we pick. Okay, here's another example. So here I've got an input-output table. Now I don't have two outputs, but that's okay. I can still find it with what I have. All I need is two pairs of numbers. I have 3 pairs. I'm good to go. So I've got 17 minus 11. And then I find my x values that coordinate. So 5 minus 3, 17 minus 11 over 5 minus 3. 17 minus 11 is 6. 5 minus 3 is 2. 6 divided by 2 is 3. So this is a slope of 3. Let's look, and here you can see I took two numbers that weren't right next to each other in the input-output table because it doesn't really matter. So I do 20 minus 11 over 6 minus 3. 20 minus 11 is 9, 6 minus 3 is 3, 9 divided by 3 gives me a slope of 3. So this still works. Now here's my third example. Instead of having a table, I just have two pairs of coordinates, -2, 3, and 2, 5. Now, to help avoid negatives, it doesn't matter what order I subtract these, but if I look, I know if I do 3 minus 5, I'm going to get a negative. So I'm going to do 5 minus 3, where is it, over 2 minus -2. Now, minus a negative, remember these two negatives come together to make plus. So 5 minus 3 is 2. 2 plus 2, or 2 minus -2 is 4. 2 over 4, that is a slope of 1/2. Now, you can get a negative slope. It's okay. If you get a negative slope, it's not a big deal. But that just means your slope is negative, or it would be going downhill. You could also get a slope of 0, remember, which is flat. Now we will go over this some more tomorrow. Make sure if you've got questions, you come prepared to ask them.